Have you ever found yourself thinking, if only I had invested in Nvidia or real estate back in 2011? Or, why couldn't I have been born earlier to catch the dot-com boom? It's natural to look back at missed opportunities and wonder, what if? But what if there was a new frontier, an emerging industry poised to explode where you could be at the forefront instead of playing catch-up? Welcome to the world of quantum computing, the next big gold rush in technology. In this video, we'll explore what quantum computing is, why it matters, and how it could reshape our world and create unprecedented opportunities for those who get in early.
Quantum computers. Quantum technology.
What on earth is a quantum computer?
Bits, qubits, try all the codes at once.
Whichever nation first develops a practical quantum computer will have a tremendous advantage.
Quantum supremacy.
Chapter 1. A brief history of computing power. To understand why quantum computing is so revolutionary, we need to look at the history of classical computing. In 1956, storing just 5 megabytes of data required a hard drive the size of a large commercial refrigerator. Fast forward to today, and we can store over 51,000 times that amount on a tiny micro SD card. The progress in computing power has been nothing short of incredible. For instance, the smartphone in your pocket has more computing power than all the computers used to send astronauts to the moon in 1969. That's how far we've come. However, we're starting to hit a wall. The pace of progress in classical computing is slowing down. Sure, computers are still getting faster year by year, but we're not seeing the exponential leaps we used to see in previous decades. This plateau is significant because computing power is at the core of nearly every aspect of our modern lives. It powers our smartphones and your laptops, runs our businesses, from small startups to giant corporations, and is essential for scientific research, from climate modeling to drug discovery. In short, the entire modern world runs on computing power. If we can't keep improving it at the same rate, we'll hit a bottleneck in technological progress across all these areas. Chapter 2. What is quantum computing? Quantum computing is a fundamentally different approach to processing information. To understand it, let's first look at how classical computers work. Classical computers use bits as their basic unit of information, where each bit can be either 0 or 1. It's like a light switch. It's either on or off. All the complex operations a computer does are based on manipulating these bits. Quantum computers, on the other hand, use quantum bits or qubits. Here's where it gets mind-bending. Thanks to the weird world of quantum physics, a qubit can be 0, 1, or both at the same time. This state of being both 0 and 1 simultaneously is called superposition. The power of superposition. This might not sound like a big deal, but it's revolutionary. With classical bits, 2 bits can be in one of 4 possible states: 0, 0, 01, 10, or 11. But with 2 qubits, you can represent all 4 of these states at the same time. As you add more qubits, the number of states that can be represented grows exponentially. With just 300 qubits, you could represent more states than there are atoms in the observable universe. This means quantum computers can process vast amounts of information simultaneously, tackling problems that would take classical computers thousands of years to solve.
We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even more historic than that. We're now at the initial stages of the next revolution. We're talking about a new generation of computers, the ultimate computer, a computer that computes on atoms, the ultimate constituents of matter itself.
Chapter 3. The quantum advantage. Real-world applications. So, quantum computers can process lots of information quickly. But what does this mean in practice? Let's look at some real-world applications that could revolutionize various industries. Artificial intelligence and machine learning. Artificial intelligence, AI, has been called the electricity of the 21st century. It's transforming everything from how we shop online to how doctors diagnose diseases. But training AI requires processing enormous amounts of data, which takes a lot of time and computing power. Quantum computers could supercharge AI, making it possible to train models on much larger datasets much more quickly. Hear from the man himself, Michio Kaku.
In application of this thing, one of the things that we're seeing right now, when we're talking about quantum computing, back to that, one of the things we're seeing now is ChatGPT.
Right.
ChatGPT, which is this fascinating AI program that essentially scours the entire internet for answers for things and is so good at it. The answers for things, for just data, people are getting diagnosed with certain diseases based on symptoms and blood work, and it's super accurate. legal papers. It could fill out legal forms, and it's wild the
You
capacity
can
that it
pass
has
the
right
bar
now.
exam that way, too.
Yes.
The bar exam can be passed with a chatbot.
Yeah, it's like 98%, right? Now, here's the question. If quantum computing gets involved in AI, what are we looking at?
Well, first of all, AI is a software program. We're talking about homogenizing different kinds of essays on the web, splicing them together, and then passing it off as your latest creation. Basically, plagiarism using digital computers. It's a software question. However, quantum computers is bigger than that. Quantum computers is a hardware question where it actually increases your ability to do much more than with an ordinary digital computer. So the two of them, the chatbots that are a revolution in software, and then quantum computers, which are a revolution in hardware, when they get together, watch out.
In finance, faster computations could enhance market analysis and investment strategies, while improved logistics and supply chain management could optimize routes and inventory in real time, saving businesses millions. Moreover, accelerated simulations of molecular interactions could lead to faster development of new treatments in drug discovery processes. Cryptography and cybersecurity. Remember how quantum computers can process vast amounts of information quickly? Well, this has huge implications for cryptography, the science of securing information. Many of our current encryption methods rely on the fact that it would take classical computers an impractically long time to crack them. But quantum computers could potentially break these encryption methods quickly, posing a significant security risk. However, it's not all bad news. Quantum computing also offers the potential for new, ultra-secure encryption methods. The race is on to develop quantum-resistant cryptography that even quantum computers can't crack, ensuring data security in a quantum world. These are just a few examples of what quantum computers can enhance. Chapter 4. The Quantum Gold Rush. Who's in the race? Just like the gold rushes of the past, the potential of quantum computing has sparked a modern-day rush, with tech giants and startups alike vying for a piece of the action. Google is one of the key players in this space. In October 2023, Google claimed to have achieved quantum supremacy, the point at which a quantum computer can perform a task that would be practically impossible for a classical computer. Their quantum computer reportedly solved a problem in 3 minutes and 20 seconds that would have taken the world's most powerful supercomputer 10,000 years to solve. Not to be outdone, IBM is also heavily invested in quantum computing. They've made a quantum computer available through the cloud and have launched the IBM Q initiative, a community developing quantum software. Similarly, Microsoft is working on its own quantum computer and has developed a quantum programming language called Q. Meanwhile, Amazon, while not building its own quantum hardware, is partnering with other companies to make quantum computing available through its cloud platform, Amazon Web Services. Alongside the tech giants, numerous startups are entering the quantum computing space. It's not just companies in the race. Countries are also competing to lead in quantum computing. China has invested heavily in quantum technology, seeing it as a key to future economic and military advantage. The European Union has launched a $1 billion quantum flagship initiative to fund quantum research, and the United States has passed the National Quantum Initiative Act to accelerate quantum research and development. Chapter 5. The Challenges Ahead. While the potential of quantum computing is enormous, there are still significant challenges to overcome. One major issue is error correction, as quantum states are extremely fragile and prone to errors. Developing effective error correction methods is crucial for building practical quantum computers. Scalability is another challenge, as current quantum computers have a limited number of qubits. Scaling up to thousands or millions of qubits while maintaining coherence is essential. Additionally, we need new algorithms and software tools specifically designed for quantum computers, as well as solutions for cooling, since many current quantum computers need to be cooled to near absolute zero to function, which is expensive and impractical for widespread use. Lastly, there's a shortage of people with the specialized skills needed to work with quantum computers, highlighting the importance of workforce development. Despite these challenges, the future of quantum computing looks bright. Experts predict that we could see practical, large-scale quantum computers within the next decade or two. When that happens, it could trigger a new technological revolution. Just as classical computers transformed every aspect of our lives over the past few decades, quantum computers could lead to breakthroughs we can only dream of today. Imagine a world where complex diseases are cured within weeks of being discovered, Financial markets are perfectly optimized, and climate change is mitigated through innovative technologies developed in record time. The possibilities are endless. To wrap things up, so what's the takeaway from all of this? The quantum computing revolution is coming, and it's going to create new opportunities for those ready to seize them. If you're interested in technology, finance, or healthcare, now is the time to start learning about quantum computing. Begin by educating yourself and familiarizing yourself with the basics of quantum mechanics and quantum computing. Join online communities or local meetups to connect with others interested in quantum computing and keep up with the latest developments in the field. The landscape is evolving rapidly, and being informed will help you stay ahead. Just like the gold rushes of the past, the quantum computing revolution is about to begin. What do you guys think about this new gold rush? Do you think it is just another hype? Or this gold rush can be real? Will you be ready to stake your claim? Please leave your comment below. We would love to hear from you.
Thank you for making it this far. If you like this video, you might want to share it with a like-minded friend. Thank you, and as always, stay blessed.